Hi, I'm Dr. Victoria Sevastianova from IMDEA Materials Institute, and this is our fourth and final video of CARDIOBOOST Science Explained. In our previous 3 videos, we've explored how LCD 3D printing is enabling the next generation of cardiac tissue engineering. In this video, we will look at how we are implementing this technique at IMDEA Materials Institute as a part of the CARDIOBOOST project. Sound interesting? Stay tuned. At IMDEA Materials, we are developing polyurethane-based resins suitable for LCD printing of cell culture platforms. Importantly, these resins must be cytocompatible. This means they support cell survival and growth. That's a big challenge and a reason why many commercial resins are not suitable for biological applications. The combination of LCD printing with the use of these cytocompatible resins enable dilute fabrication of micropatterned structures with high precision, while simplifying all manufacturing process. And the results are remarkable. Here you can see muscle cells attaching and growing on the printed polyurethane platforms. The cells spread along the micropatterns and become aligned. This closely resembles the organization found in native muscle tissue. The ability to guide cell behavior using engineered microstructures, creating exciting possibilities for regenerative medicine, disease modeling, and future biofabrication. This work is part of the CARDIOBOOST project led by the Spanish National Center of the Cardiovascular Research and funded by the Community of Madrid. By combining material science, biology, and advanced manufacturing, LCD printing is becoming a powerful tool for engineering the microscopic environments that cells need to thrive. And sometimes simply helping cells organize themselves is the first step toward helping tissues heal themselves. I'm Dr. Victoria Sevastianova from IMDEA Materials Institute, and this has been CARDIOBOOST Science Explained. Thank you for watching. So it's a very simple sentence. As a part of CARDIOBOOST. I forgot to say.
That just kind of ended very abruptly.